So what you see here is a picture and a painting that my family has on the wall. We kind of like the idea of having some quadrilateral designs going on here, and so what we've done is taken 4 tiles, those brown things that you see, and hung them on the wall with a picture inside. And then we wanted to create a painting around that using the edges of those tiles as kind of guidelines, and we created a quadrilateral with that. So I am curious, what type of a quadrilateral did we really end up painting? And so we're going to do some thinking with that. So now what you see is a mathematical rendering of that wall decoration that my family has. Notice that I've labeled the quadrilateral ABCD, and that's what I'm going to try to figure out what it is. I've also labeled the origin 0, 0 at one corner of those tiles. The tiles are rectangular, and I don't really know the measurements of them, and I don't really care, so I've just labeled them as X and Y. So now I'm going to figure out a whole lot more about the coordinates within this shape. Now I think you see that I've labeled a few of the points within the figure using the dimensions. Notice that that first tile on the left is X across and Y up, so then the coordinates of the other endpoints would be X, 0 and 0, Y. Then on the bottom tile, the dimensions, that tile's been rotated, so instead of X by Y, it's now Y by X, and so continuing across from X, 0, the next coordinate will be X plus Y, 0. And continuing across with the right-hand tile, it's again the same as the left hand, where it's X by Y, and so the coordinates of that right-hand point below C is 2X plus Y, 0. Now I'd like for you to take a moment, pause the video, and see if you can fill in the remaining coordinates. Okay, well, here's what I've got. How did you do? Hopefully you did pretty well. My next step is to find the coordinates of A, B, C, and D so that I can prove what type of a quadrilateral it is. I've focused you in here on the part with A so that we can find its coordinates. I'll use the same reasoning later to find the coordinates of B, C, and D. Notice that I've drawn the altitude / median / angle bisector from A to the tile, and then copied that segment down so that I can create the triangle down to the origin from A and from the tile. Since this is an altitude and a median and an angle bisector and a perpendicular bisector, then what I know is that the length of both of those red dotted line segments is half of y. That gets me the coordinates of A very easily. I've now used that same logic to find the coordinates of B, C, and D. Hopefully you agree with my thinking. My conjecture is that ABCD is a square, and so my goal will be to prove that it is that. I'll need to find the lengths of each side as well as find the angles and show that they're 90-degree angles. To find the lengths, I just use the distance formula, which is change in x squared plus change in y squared. And for AB in specific, I see that from negative half y to x plus 1/2 y, the change in x is a full x and a full y, or x plus y. And to go from half a y to x plus 1.5 y, the change in y is also x plus y. So the length of AB is the square root of x plus y squared plus x plus y squared. I can't simplify that any further, so I'm just going to leave that as it is. Now looking at BC, I see that the change in x is also x plus y, and the change in y is x plus y. So the length of BC is also the square root of x plus y squared plus x plus y squared. The length of CD turns out to be the same, as does the length of AD. So, without simplifying or finding a specific numerical value, I've found that the lengths of all of them are shown by the expression x plus y quantity squared plus x plus y quantity squared, all inside of a square root. Using the same change in y and change in x, I can also get the slope, which is change in y over change in x. That is x plus y over x plus y equals 1 for both AB and for CD. I need to be a little more careful for BC and for AD because the change in y is actually going down. It's a negative value. So if I do negative of x plus y over x plus y, then I will just get negative 1 for my slopes. Now that I've shown that the lengths of AB, CD, BC, and AD are all the same expression, I can conclude that those four segments are equal. And since I've shown that AB has a slope of 1 and CD has a slope of 1, and BC and AD have slopes of negative 1, then I can conclude that those slopes are opposite reciprocals of each other, making adjacent sides perpendicular. Since those things are true, I have a quadrilateral with 4 congruent sides and 4 right angles. Thus, ABCD is a square by the definition of square. And I'm done! QED.